Hi everybody, this is Dr. Hammond. These are the notes for Phys 3210, electromagnetic waves. In this lecture, we're going to be talking about finishing up radiation and discussing radiation reaction, and then beginning to discuss special relativity. So I want to reiterate some of these things that I've posted. So due dates were originally pushed back. We had a meeting on Friday afternoon saying that because of the class cancellation from Monday to Wednesday, everything's going to be pushed back, and so we can push back our due dates as well. But then we got a memo on Monday saying that that's no longer true. But of course, that was after we had posted our announcements and emailed students saying that everything had been changed. So I've pushed back the assignment that was supposed to be due today to Tuesday. However, that means that the last assignment that we would have had that would have been assigned today, I'm not going to assign it as mandatory. I'll give it out on Tuesday and I will make it optional. I can't have it due after Friday, March 27th, because that's the last day that anything can be actually handed in. However, I will still accept it until Tuesday, March 31st, without taking off any marks or anything like that. So sorry for the confusion on that. I guess that also applies to the labs. Originally, they would be due at your lab section on next week, either Monday or Tuesday. But those have all been pushed back to Friday on March 27th as well. But that's the last they can be. That's the last they can be handed in, or the last day they can be handed in. Email Jake if you have any questions. I think on the updated syllabus I have his email on that in case you didn't have it before. We will continue with these daily assignments. So to make sure that everybody's kind of reading along and actually listening to these videos and things like that. I want to still have these daily assignments where you kind of read the material beforehand and just kind of summarize your thoughts on it, just so that I know that you've read it before. I'd prefer if you actually email me sometime that day this little, half-page write-up, so that I can kind of keep track of who submitted something. Because otherwise it'll get lost in the flurry of emails from everybody in the university. I've interspersed these slides with images from XKCD or strips from XKCD because I find that he has a good take on what's going on in the world or what's going on in physics that is far wittier or and funnier than I could ever be. All right, so to talk about the final exam, so as I posted to you guys, the final exam is going to be a project instead. I thought we could do a take-home exam, but then I need to make sure that you have several hours of dedicated time, uninterrupted time, and since everybody's now working from home, you probably have family members in close proximity that make it distracting. So instead of doing that for this course, I'm going to have a project. So it'll be a poster that you present, or that you would present at, say, You'll Discover. So I've uploaded several different ideas, about a dozen different ideas, and about a dozen of you in the class, so each of you guys get an idea. But I think if you don't like what you see, or everything that you see is already taken, feel free to come up with your own idea. However, just make sure that you pass it by me so that I can make sure that it's kind of the same caliber of everybody else's project. I really want you to be excited about this, so I want you guys to find something that is related to electricity and magnetism that is that's kind of exciting and gets you motivated to learn something more about the subject. We could have a final exam on 4 vectors and tensor notation in electromagnetic radiation, but I feel like for most people that is not particularly interesting or particularly useful, whereas say understanding how you know, an electric motor works or how an antenna can direct radiation might be a little bit more interesting if you guys are looking at, you know, building stuff and things like that. So contact me if you have questions about that. I would like to be able to discuss with you somehow, either through email or maybe Skype or something like that, to kind of just like make sure that your projects are coming along and are kind of on the you know, scale of what I'm expecting. So they're due in about 4 weeks. So they're due the day that your exam was originally scheduled, so Thursday, April 16th, which is about 4 weeks from now. So I expect you to spend about 15 to 20 hours on this project. I feel like that's about how much time you'd spend studying on a final exam. And I feel like in that time, you'd be able to get a pretty good poster going. I will upload PowerPoint templates in case if you've never done a poster before, so that you can kind of see how these things are made. But yeah, since you have 4 weeks, it's about 5 hours a week, which I feel is, you know, pretty reasonable for you to get a good poster out of this. All right, so the point of this lecture is to get us back up to speed with radiation. Most importantly, what is the cause of radiation? That's like the single most important thing that I want you to get out of this is what is the actual cause of radiation. We'll be discussing the Larmor formula and how we'll use an example of the Bohr atom to show that the Larmor formula would predict that the universe collapses on itself within 16 picoseconds. So obviously the Bohr model isn't a very complete model of how an atom works, but it's just to give you an idea of some of these, you know, numbers that we'll be dealing with radiation and power dissipation. But this leads to radiation reaction, which is basically a consequence of having an electric charge that will radiate. And so because it's radiating, it's losing power, and that seems to kind of lead to some weird consequences that still aren't fully understood now. I like this XKCD comic of somebody going back in time. Of course, if a time machine were invented, it would be invented by an electrical engineer, and the electrical engineer would go back and think that the #1 most important thing is that Benjamin Franklin has confused what carries the current, whether it's the positive charge or the electric charge, and say that instead the charge left on the glass by the silica should be negative instead of positive. And so that means that our current, which, you know, is how we describe it as a positive charge, it's actually the electron, because that would make our right-hand rules make much more sense. All right, and so I want these recordings to last about 10 minutes or so, because I feel like that's about all I have the the attention span for talking about these subjects. So I'll just be dividing these up into about 10-minute chunks, and that way if you want to go back to something, it's easier to find that recording. So yeah, that is the end of this first one, and when we come back, we'll be discussing the source of radiation and the Bohr model and how that relates to radiation.